Hey guys, we are factoring today and we are looking at a specific type of factoring. There's a bunch of different ways you can factor, right? We are looking specifically at the sum or difference of two cubes. You can use this strategy when you notice you have two terms that are being added or subtracted together and they're both perfect cubes. Now, if you're like, I don't remember what that means, we're going to go over it. So you're probably pretty familiar with square roots. Like the square root of 16 is 4. And why is that? Because when I do a square root, it's asking me what number multiplied by itself will give me 16. So because 4 times 4 is 16, the square root of 16 is 4, right? Now, cubed root is really the same thing. We are just asking, you probably guessed it, what number multiplied by itself 3 times will give me the number that's over here? We put a little 3 to signify that. So for example, the square root of 125 would be 5. And that's because 5 times 5 times 5 times itself 3 times is 125. So as you can probably imagine, there are a lot of numbers that do not have a pretty cubed root. You're going to get an ugly, nasty decimal. So a perfect cube is when we get a nice integer for our answer, like 5 or 10 or 4, right? So that is what a perfect cube is. So when I know I'm going to be working with problems like this, I tend to like to write them out so that I just have these ones right here that I know are perfect cubes. Now, as you work with problems like this more, you will start to recognize these numbers just right off, but I like to have them written out just to help me. All right, now let's go ahead and look at a problem. Okay, so like we said, this is a specific special factoring strategy when I am looking at something I need a factor and I notice that I have two terms that are perfect cubes. So let's see if this falls into that category. So like we said, I would use this strategy if I were factoring and I noticed that I had two terms being added or subtracted together and they are both perfect cubes. So let's look at this problem and see if it fits into that category. So I want to be able to write this as a term cubed plus a term cubed. So we are close here. I've got s cubed and t cubed, but what about 64? Is that a perfect cube? So I have my nice little list here, and look, there's 64. 64 is 4 cubed. All right, so I can rewrite this little problem here as, I'm going to use parentheses, s cubed, okay, that's fair, plus, remember we said 4 cubed is 64, and t cubed is going to give me t cubed. So I could write 64t cubed as 4t cubed. Is that fair? If I were to multiply 4t times itself 3 times, would I get 64t cubed? I would. All right. So this is the same thing, just written a little bit differently. And now it fits with my sum of two cubes. All right. So now I have s is my x and 4t is my y. One thing we do always need to remember when we are factoring is to always check to see if we can pull out a greatest common factor before we start to factor. So this one didn't have it, so I forgot to mention it. Sorry. But if you need a review on that, I will link a video for you in the corner. But let's go ahead and use this now. So we're labeling s is our x, 4t is our y. We could also write it over here if that is helpful, that when we are plugging it in here, we are plugging in s for x and 4t for y. So I would have x plus y, or s plus 4t, times x squared. So s squared minus x times y. So s times 4t. So I'm going to write that as 4st plus y squared, which we have 4t. When I square 4t, I'm going to get 4 times 4 is 16, and t squared is t squared. So plus 16t squared. And look at that. We are factored, ladies and gentlemen. All right, that fit our category because we were able to write it as a term cubed plus a term cubed. Now let's check out this one down here and see if we can make this one work. Well, I have m cubed, so we're good. Then I have n cubed, but what about 27? Is that a perfect cube? Oh, look, it is. 3 cubed is 27. So I can rewrite this as m cubed minus 27 can be rewritten as 3 cubed. So we can write this as 3n cubed. Because with 3n times 3n times 3n give me 27n cubed. Yes. All right. Now we're going to use the difference because we're subtracting. So again, we have that x equals m and y equals 3n. All right, let's plug this in. So I'm going to have x, which is m, minus y, so 3n, times x squared, which is m, so m squared, plus x times y, so m times 3n. I'm going to write it as 3mn, plus y squared, so 3n squared is going to be 9n squared. All right, there we go. I forgot to mention up here that you can always check your answer by multiplying it back out. Make sure you get this. Same here. Multiply it out. Make sure you get that. All right, I will link some more videos if you need them. Thanks.